Good morning to one and all present here. I'm Ramya Devi, working as Assistant Professor in SNS College of Technology. Today I'm going to share a small article regarding recursion and how it is used in Python program. So what is a recursion? A recursion is basically a function calls itself. Like that, like when we have a bigger problem, we'll divide that into a smaller ones and then we'll solve it. So in this video, we are going to see introduction to recursion, basic concepts of recursion, and also how to implement recursion in Python. So first we'll see introduction to recursion. So when it comes to definition of recursion, recursion is a programming technique where a function calls itself to solve smaller instances of the same problem, ultimately breaking down into a manageable parts. Like we have a bigger problem, and that has been divided into smaller ones so that it can be solved easily. So how the recursion works? So recursion operates by maintaining a function call stack that tracks each function call, which allows a program to return to previous calls once a base case is reached. So whenever a base case is reached, it goes to the main function and then it calls itself. So how the problem solving, what is the importance of recursion? So the recursion is mainly used for problem solving and also versus iteration. So recursion simplifies the complex problems by breaking them down into smaller problems, making it easier to develop solutions for tasks like searching and sorting. And also recursion when it comes for iteration, while both recursion and iteration are used to repeat actions, so recursion offers a clearer and more elegant approach for problems that naturally fit its structure like tree traversal. So now we'll come to the basic concepts of recursion. So the what are the basic elements of a recursive function? It has two cases. One is a base case, the other one is a recursive case. So the base case is a condition that stops the recursion, preventing the infinite loops. So it serves as a simple answer for specific input values and also ensures whether the function has been completed successfully or not. So when it comes for recursive case, the recursive case is the part of the function that includes the recursive call. It breaks down the problem into smaller subproblems to be solved identically and moving towards the base case. And also, now we'll see the common use cases for recursion. So the factorial calculation, Fibonacci sequence, these are the common cases used for recursion. So when it comes to a factorial function, so the recursion elegantly computes the factorial of a number by multiplying the number by factorial of the number minus 1, continuing until it reaches 1, the base case. So here it calls the factorial function itself whenever it is needed, and once a base case has been reached so that it stops. So it elegantly computes the factorial of a number by multiplying out the number by the factorial of the number itself, and also it minuses by 1. So and it also continues until the base case has been reached. So when it comes to Fibonacci sequence, the Fibonacci sequence can be generated using recursion by summing the two preceding numbers in the sequence. So which highlights the power of recursion in mathematical calculations, so that the Fibonacci sequence can be generated by summing the two of the preceding numbers until the base case has been reached. So how now we'll see how to implement the recursion in Python. So first we are going to write your first recursive function. For example, when you take factorial function, here the factorial function will be always serves as a classic example of recursion, which computes the product of all positive integers up to a given number, which illustrates the concept of recursive calls. And also when it comes to Fibonacci function, the Fibonacci function generates a Fibonacci numbers by recursively computing the sum of two preceding numbers, which provides insights into the power and elegance of a recursive programming. So when it comes to the debugging or recursive functions, so the common errors to when we have to watch when it comes to recursive function is it should not go into an infinite loop. So when working with recursion, the common errors include infinite recursion and stack overflow. So these are the common errors which may happen when base cases are not defined properly or are missing altogether. So when it comes for techniques for debugging recursion, so debugging recursion can be effectively tackled by utilizing print statements and also visualizing the callback or employing debugging tools to step through recursive calls for clarity.